Alright, if you have watched part 1, you know what an LLM is. It predicts the next word over and over. That's the whole game. But here's the thing, why does that work? I mean, really. Why would predicting the next word produce anything that looks like intelligence? That sounds too simple, too dumb. There has to be more to it. Today we are going to answer that question. And I'll warn you now, this one going to mess with your head a little bit. Because to understand why prediction work, we have to ask a much more dangerous question. What is language actually made of? If this clicks today, I promise you, LLM will never feel mysterious again. So let's go. Quick recap. Last time we established the foundation. An LLM is the next token prediction machine. Neural network plus massive data plus predict what comes next. Done? That's our bedrock. We are not questioning that anymore. Today, question sits one level deeper. Why does predicting next word work at all? What is it about language, about the structure of human communication that makes prediction so powerful? To answer that, we need to kill something first. A myth. A very old, very stubborn myth about how language works. Most people think language work like this. There are grammar rules, dictionaries with definition, sentence structures, formulas. And when you speak, you are somehow following these rules, obeying the system. That's not how it works. That's not how it works at all. And I can prove it to you with one sentence. The cat happiness jump blue. Now, why does that sound wrong? Think about it. What rule does it break? Is there a grammar rule that says you cannot put happiness after cat? No. Cat can be followed by a lot of nouns. The cat food, the cat owner. Is there a rule against jumped after happiness? Not really. Subject can be followed by verbs. Is blue grammatically illegal at the end? No. The sky turned blue. Right? Totally fine. So what's the problem? The problem is that you have never seen this pattern all together. Your brain isn't checking rules. Your brain is checking experience. And your experience says these words don't go together. I have never encountered this combination. Something is wrong. The sentence violates statistical explanation, not grammatical laws. This is huge. This changes everything. Language is not rule first. Language is experience first. Okay, if language isn't about rules, what is it about? Here's the mental model I want you to hold. Think of language as a river, not a rule. Every word you say pushes you down certain path. Narrow possibilities guide you towards likely next word. Let me show you. Complete this sentence. I drank a cup of coffee, probably. Tea, maybe water. Possibly juice if you are feeling healthy. Now, did you think concrete? No, of course not. The probability of concrete after cup of is essentially zero. You would never say it, you would never consider it, and you didn't check any rules to know that, right? Your brain just filtered automatically, instantly. Here's the key idea. Actually, write it down. Language is a distribution over possible continuation. Every word you hear shifts the probability landscape. Some next words become likely, others become nearly impossible. And you are navigating this landscape constantly, unconsciously, with every sentence you hear or speak. That's what's LLM exploit. They are not learning rules. They are they are learning the probability landscape of language. Let's make this really simple. Like explain it to a 12-year-old simple. Okay. Imagine you have a bag. Inside the bag are colored balls. Each color represent a possible next word. After I drank a cup of, right? You have to complete that sentence. So there are maybe 50 brown balls labeled tea, 40 dark balls labeled coffee, 9 orange ball labeled juice, and one weird ball labeled sand. Now, if you close your eyes and pull out a ball, what do you get? Probability, maybe coffee, occasionally juice. Sand, you have to be incredibly lucky, 1 in 100, right? This is what an LLM does. But instead of one bag, it builds millions of bags. One bag for drank a cup of, one bag for the president announced, one bag for she looked at him. And each bag has a different balls, different probabilities, different likely continuation. The model doesn't know which word is right. It doesn't have opinion. It just reaches into the appropriate bag and pulls out a ball. Sometimes it gets tea, sometimes coffee, very rarely sand. That's the randomness. That's why the same prompt can give different answer. Now here's where it gets little uncomfortable. I'm going to tell you something that might sound wrong at first. Word Words don't have meaning by themselves. I know, that sounds crazy. Of course, words have meaning. Dog means dog. Bank means bank. Does it do? What does bank mean? Well, it depends. I need to go to the bank. At this point of time, bank has a different context. Financial institution. We sat on the river bank. At this time, the bank has a different context. Edge of water. Right? Three completely different meanings, same word. What change? Context. The meaning doesn't live inside the word. The meaning emerges when the word meets its neighbors, when context narrows the possibility. This is crucial for understanding LLM. They don't store definition. They are not dictionaries. They store how words behave more around other words. What context they appear in, the pattern they form. And when you give them a context, they don't look up a definition, they reconstruct the meaning of the patterns. That's why they seem to understand. They don't, not really, but they approximate context so well that the effect looks like understanding. Okay, I want to give you a picture to hold in your mind, a metaphor that might help this click. Imagine a giant map, like a map of a country, but for language. Every word is a city on this map, and between the cities are roads. Some roads are highway, massive, heavily traveled. These are common word transition, quick to brown, brown to fox. When you speak a sentence, you are taking a journey across this map, city to city, word to word, following roads. And here is the thing, LLMs have learned the entire road system. Every highway, every side road, every dirt trail. They know how likely you are to travel each path from any city in any direction. Your sentence is a journey. The model knows all possible routes. That's what makes prediction work. It's not guessing randomly. It's navigating a map it has completely memorized. Okay, but why rules fail? Let's stress test this idea a little bit. If a language were really about rules, we should be able to write them down, right? Explicitly. Okay, try this. Write me the rules for when a joke is funny versus when a joke is offensive. Go ahead, I'll wait. Can't do it, can you? Because there are no rules. These are just patterns. Example, cases where it worked and cases where it didn't. How about sarcasm? Write me rules for detecting when someone mean opposite of what they are saying. How about poetry? Emotional comfort? You can't. These things are too complex, too contextual, too dependent on history and culture and the specific humans involved. But you know what we do have? Examples. Billions of them. Billions of jokes, millions of sarcastic remarks, millions of poem, all written down, all recorded. Here's the core idea. When systems are too complex for rules, nature uses statistics. You can't write these rules, but you can learn the pattern. Language is such a system. Alright, now we can finally answer the question we started with. Why does predicting next word produce anything that looks like intelligence? Think about what reasoning looks like when it's written down. Step 0 lead to step 1, lead to step 2, and that leads to conclusion. Each steps follow predictably from the one before. That's what makes it reasoning. That's what makes it logical. If then, if then, if then. Now imagine a model that has seen millions of these chains, mathematical proofs, scientific arguments, logical deductions, philosophical reasons, code that build function by function. What has it learned? If it learned the shape of reasoning, the statistical pattern, how step n plus 1 follow step 1 through n. So, when you give it a reasoning problem, what does it do? It doesn't reason, it doesn't think, it predict reasoning shaped text. And these reasonings are consistent. This reasoning has consistent shape because logic follow pattern. The prediction often follows like actual reasoning. That's why proof work. That's why code work. That's why explanation work. Not because models understand, but because it has given so many examples of understanding that it can continue the pattern. Now I have to be honest with you here. Intellectually honest. We have talked about how powerful this is, and it is powerful, remarkably so. But we can't get drunk on this magic. Here's what LLM are: brilliant pattern matching machines, the best we have ever built. They model the statistics, they model the statistical structure of the language better than anything in history. Here's what they are not: they don't know truth, they don't know fact checker inside, they don't verify claims against reality, they don't ground meaning in the real world. They have never seen a cup of coffee, they have never felt cold, they have never been disappointed. They model language, not the world. This matters. This is where the mistakes come from: the hallucination, the confident nonsense. The model can produce perfect sounding text that is completely false it because it's not checking truth, it's checking patterns. And sometimes false things follow true sounding patterns. We'll fix this later. There are ways to ground these models, you know, tools, retrieval system, fact checking mechanism. But first, we have to understand what we have built on. And what we are building on is pattern, not truth. Okay, let's make sure this landed. If I stopped you right now and asked, why does predicting next word works? Could you answer? Here's what you should be asked. You should be able to say one sentence. Language works because words follow statistical pattern, not fixed rules, and predicting this pattern is enough to produce fluent, meaningful text. If that sentence feels solid, if you have explained it to someone else, you have got it. You have understand why LLM works at a fundamental level. If it feels shaky, no shame. Watch this again. Let the idea settle. Understanding is built in layers. You know, look at the complete picture. The fluent language equal to summation on all the context where probability of next word is given the current context, right? Once you internalize this, once you really feel the language is pattern not rules, everything else about LLM start to make sense. The power makes sense, the limitation makes sense, the weird failure makes sense. You stop being mystified, you start being curious. And that's when it gets really interesting. That's part 2. If you're still with me, you now understand something that most people don't. Language isn't rule, it's pattern, and patterns can be learned. Next time we are going to look inside the machine. How does a neural network actually learn these patterns? What's going on under the hood? That's where it gets technical, but I'll keep it human, promise. Hit subscribe if you want the next one. Drop a comment with your answer to the test question. I want to hear you explain it in your own words. And if you know someone who is mystified by AI, then send them this video. Let's demystify together. Alright, go notice some patterns.